So this is our notes for section 9.4, just graphing parabolas, so not getting the solutions to it, although maybe this will fit on the back half of this. So step number 1, graphing parabolas. That's what we're going to do right now. So on the top of your notes, we have a 4-step process here for graphing quadratics, which makes a parabola. Recall that if A is positive in our quadratic equation here, that it'll open up. If A is greater than 0, and if A is less than 0 or negative, it will open down. So keep that in mind about how things should look. We've been identifying A, B, and C, but step number 1 says write the equation in the form ax squared plus bx plus c equals 0. We have to have this equation set equal to 0. Let's set equal to 3 here, so we need to undo that algebraically. So on each side of the equation, I'll subtract 3. That gives me 0 on the right side of the equal sign. Now on the left side, I can't combine that negative 3 with the x term or the x squared term. So I'm left with x squared minus 2x minus 3. That's my new equation. So A is 1, B is negative 2, and C is negative 3. So I've written the equation in this form, although actually, so I can replace that 0 with a y. And then again, I found the A, B, and C value because for step 3, I'm going to find the x value of the vertex, like we've been doing before this. The day before this, for many of us, our task was just to do this, get the vertex x value. So let's try that. So I guess I'll have to work down here because I'm running out of room. Vertex x is the opposite of b divided by 2 times a. So that's going to be positive 2 because b is a negative 2. So the opposite of a negative 2 is a positive 2. Underneath, I always have a 2, and it's always multiplied with a, and a is 1. So let's simplify the bottom before we divide. So it's really 2 on the bottom because 2 times 1 is 2. So then I get 1. So now we're going to make an input-output table, and we're going to plug the vertex value into the equation and calculate the y value of the vertex. Now what I'd encourage you to do is to put, so look how long this column is here for the x's, put your vertex x value in the middle. Now I'm going to use that x value to calculate y. So I'm going to take this equation that had y or 0 on one side, and I'm going to plug 1 in for x. So 1 squared minus 2 times 1 minus 3. You can use Desmos Scientific Calculator here. In my head, I am getting negative 4. I hope that's correct, but I'm not sure. So in other words, when x is 1, y is negative 4. So that is right there. By the way, remember, this is, when I look at the coefficient of x squared, it's a positive. It's an invisible positive 1. So I'm thinking this should be going up. And so I've just located the vertexes right here. Now remember, parabolas are symmetrical. There is a line of symmetry going through the vertex, a vertical line. So whatever my y value is just to the left, say 1 value to the left for the x, my y value should be the same as the position that is 1 value to the right of the x coordinate. Let me give you a picture of this. So here's my vertex x value. I'm going to go 1 position to the left and 1 position to the right from the vertex, and I should get the same output. So here I'm going to plug in 0 for x. Now when I do this, I get negative 3. When x is 0, y is negative 3. Let me plug in 2. So 2 squared is 4, minus 2 times 2, that's 4. So really I get 4 minus 4 minus 3. That is negative 3. When x is 2, y is negative 3. So those points match up. They're symmetrical about the line x equals 1, or about that vertical line. Last but not least, let's go one more step to the left, so negative 1, and one more step to the right, so positive 3. Always make sure you use parentheses when you substitute the value in for the squared term especially. So here I'm getting positive 1 minus, well, that's going to be positive as well. So it's positive 1, positive 2. I get 0. And on the bottom here, you will also get 0. So when x is negative 1, y is 0. When x is positive 3, y is 0. Again, we have these symmetrical points. So then I want 5 points when you graph your parabolas. And I'd like those 5 points to be centered around the vertex. So I can see both arms, if we want to call this an arm, 1 arm, 2 arms. So I can see both arms of the parabola. Cool beans. All right, let's try one more. I think I cut off an example this year to save some space because this stuff takes some room. So let's try this one. So we need to set this thing equal to 0, and it's not, so we need to add 8x. We can't combine x's and x squared, so we have 2x squared on the left, and a positive 8x equals 0, because these things canceled out. So a equals 2, b equals 8, and c equals 0. Sometimes there is no b value or no c value, in which case it's a 0. So let's get our vertex x value. So we're going to do the opposite of b divided by 2 times a. So the b value is 8, so we need to do a negative 8. And on the bottom we're going to take 2 times our a value, and the a value is 2. So we really get negative 8 divided by 4, which is negative 2. On your XY input-output table, negative 2 goes in the center of your column for the x's, or your inputs. And then you'll have 2 numbers to the left. Actually, what I just gave you was 2 numbers to the right, which is fine. The order doesn't matter. But negative 2 should be the middle of 5 numbers. So to find the actual coordinate of the vertex, plug in negative 2 for the equation where we've set the equation equal to 0 or replaced it with a y, either or, right there. So I'm going to plug it into that equation. And really, I guess we should plug that in, or we should replace the 0 with a y, because I want to know when x is negative 2, what is y. So 2 times negative 2 squared plus 8 times negative 2. And when I plug that in, I get 4. 4 times 2 is 8. Plus negative 16. I'm getting negative 8 in my head. So negative 2, comma negative 8. Right about there. So I'm going to move one spot to the left. So I'm going to plug negative 3 in for x and figure out what y is then. When I do that, I believe I get negative 6. And I'm going to plug negative 1 in for x to move 1 to the right of the vertex. And let's see here, this one's easier to calculate. I get negative 8, positive 2, so that is negative 6. So negative 3, negative 6, negative 1, negative 6. And then last but not least, I'll plug in 0 for x and negative 4 for x. Here I get 0. Can you guess what you should get down here when you plug in negative 4? That's right, because of the symmetry, you should get the same thing. Up here I'm 2 steps to the left of the vertex, and down here at negative, I'm 2 steps to the right of the vertex, and I get 0. When I'm 2 steps to the left of the vertex, or the line of symmetry, I should be at the same height. There we are, and that is true. So there are your 5 points that are centered around the vertex, including the vertex. Whoa. And you just see, that brings up a good point. And just see your dots, and you just see the points and the math behind it. I don't care how good you are at making it a smooth, nice parabola. Excuse me, but please do try to make it U-y on the bottom, curvy on the bottom. It's not a V. It's not a half pipe. It is a half pipe. It's not this. If you had some roller skater trying to go down this thing, that wouldn't be cool. Make it curvy as best you can.